focus on some organisms that are a lot smaller and more secretive than gopher tortoises, and that we really have questions about, even though they're very common species and we see them all the time, we don't always know what they're doing. So I will turn it over to Theresa. Thank you very much for all your hard work these last 8 months. Good job on the project. You can talk about the effect of time and fire on terrestrial habitat by Pinewoods Treefrogs.
Cool. Okay. Hello, everyone. So like Betsy said, thank you for that. My name is Theresa, and I worked on the effects of time since fire on terrestrial habitat use by Pinewoods Treefrogs in the Florida scrub. Great. So just a quick overview on fire in the Florida scrub. It's important for maintaining a lot of ecosystems, and it can be managed through prescribed burns like the one that we had going on site today. There are long-term effects of these fire regimes, and they're often studied at the ecosystem level. There has been some research on how it can affect certain species, but those are limited to just a few species in the Florida scrub, such as the Florida scrub jays, sand skinks, and scrub lizards. And so there are a lot of more specific species that we don't have that kind of information on. Hello. Okay. Oh, I'll go there. Thinking. One of those species is the Pinewoods tree frog. They are Dryophytes femoralis, and there are these cute little tiny tree frogs. They're about 1 inch long. If you've been living on station, you might have been seeing them on some of the buildings, and they're calling now from the pine trees. They are abundant here at Archbold Biological Station, and they are really dependent on our seasonal ponds that we have out there in the scrub. These ponds dry down in the winters and fill up in the summer, so there isn't a persistent fish population that can predate these young tadpoles. So these frogs go to the ponds during the breeding season, they breed there, and then their larvae develop in those ponds. So there's a lot of focus on that time of their life cycle when they're using these ponds, but their terrestrial habitat use that happens outside of the breeding season can be extensive. There just isn't so much information about that on frogs in general and on the specific species. So I wanted to combine these different things, fire and terrestrial habitat use of the Pinewoods tree frogs, and look at some questions regarding that. So we know that fire can greatly alter vegetation density and structure, microclimate, and prey abundance, and that can vary with differing time since fires. But to what extent that variation happens, specifics aren't as well known. So I'm looking at how post-fire successional changes create more favorable conditions for tree frogs. Specifically, I thought that positive effects of time since fire on tree frog abundance in terrestrial habitat would occur. So as it's been more time since a fire, I would expect to see more frogs as measured through occupancy. Cool. So this is a map of some of the sites that I was looking at. So I wanted to look at some long unburned sites. So those had burned 22 years ago. Intermediately, the ones had burned 9 years ago, and then recently burned those that had burned 2 years ago. And so these are these pretty big areas here. The colored areas are the more specific areas of the time since fire that I wanted to look at. They were controlled for things like scrubby flatwoods vegetation, which is a type of vegetation out here in the scrub. It's a lot of scrubby oaks, palmettos, and interspersed with pine trees. And it is near the ponds, but not in the ponds. So during the wet season, they don't flood. So it is still a truly terrestrial environment while there is a source of juvenile recruitment from the ponds. I also want there to be a fire severity of greater than equal to 2, which basically means that in the last fire, that vegetation burned completely. And so I wanted to be able to say that this area had truly burned and not patchiness. Also, some other things was that I wanted the edge of the plots to be 10 to 60 meters from wetlands to help control for the impact of that, because there could be frogs coming from the wetlands. Cool. So some of the things that I measured for the environment, I wanted to get an idea of what the environment where all of these plots are. Wait, point on the plots. They were randomly placed within these zones, and there's 10 of them in each time since fire area for a total of 30 plots. So then at each of the plots, we wanted to go ahead and measure things like vegetation, microclimate, and the wetlands. So for vegetation, I measured the mean canopy cover, which you can kind of see here. That's the way that I measured that. Mean bare ground as a percent, mean height of the 3 tallest shrubs, distance to the nearest pine, and the species of the nearest pine and species of the palmetto. There was a central palmetto in between the pipes, and we'll get a little bit more into the plot setup, but I also wanted to check on that. For microclimate, we were going to be measuring some data for temperature and relative humidity using these terrestrial drop 2 data loggers. We only had 10 data loggers, so they were cycled within all of the plots, but each plot was measured for 2 whole weeks non-consecutively. And for wetlands, we didn't expect that fire would create wetlands or get rid of wetlands or anything like that, but we wanted to say that the wetlands weren't varying significantly with time-sense fires, even though we had controlled for that. So we wanted to check that as well by looking at distance to nearest wetland and the wetland area within 100 meters of the plot. And so what did we expect to find from that? We were looking to see that as time-sense fire increases, the mean canopy cover would increase, mean height of the 3 tallest shrubs would increase, mean percent bare ground would decrease, and distance to nearest pine would decrease. Generally, as time-sense fire would increase, the vegetation would increase generally, become more dense, become more abundant. And at the microclimate level, we were expecting to see with increasing time-sense fire, the temperature would decrease and relative humidity would increase as these things became more shaded with the increased vegetation. And now I've been telling you about these plots, these palmettos. What does it look like? So we have 2 pipes centered around a palmetto. They were either scrub palmettos or saw palmettos, and the orientation around the pipe was the palmetto was randomized. Each of the pipes are 60 centimeters tall. They have 2 different sizes, and there was a max water level of 15 centimeters. We were trying to go ahead and create the most inviting environment possible for these frogs. There have been studies that shown when they're closer to vegetation, you get higher. There are more occupancies by frogs, as well as if there's water on the bottom to create a moister microenvironment. And also the 2 different sizes of the pipes. So this one on the left here was the small one, had an internal diameter of 3.8 centimeters, and this one was the large one, internal diameter of 5.1 centimeters. The reason for this was that when this study was originally designed, I was looking to see and capture all of the tree frogs that we have here on station. So we were expecting to see larger frogs like Cuban tree frog and barking tree frog in the large pipe. And then the smaller pipe, we'd get smaller frogs like the green tree frog, squirrel tree frog, and the Pinewoods tree frog. As you might have noticed from the presentation's title, Pinewoods tree frogs. Those are the only ones that we saw, and they ended up being in both pipes, sometimes multiple in each pipe, 1 in each pipe, etc. But those are the only frogs that we saw in the pipes. But yeah, there it goes. Okay, cool. Frogs. So I went ahead and visited these 30 plots twice a week over the course of 6 weeks in February and March. And when I was going to them, I went to see if there's a frog. So if there was a frog, you can see here, little guy poking out, I wanted to go ahead and take it out. So in order to see what kind of frog it was, you can't really tell from this angle because a lot of these frogs look pretty similar. So in order to do that, this whole setup had a stake in the ground. This pipe is zip tied to the thing. There's a cap on the bottom, and I've been filling them up with water every time I went to keep those water levels up. But in that case, I can't really move frog out through the pipe. It has to come out through the top. And so in order to do that, I have this thin PVC pipe balloon tool that I made up. And basically, there's a balloon at the end of the PVC pipe. You put it in past the frog. I inflated the balloon through the pipe. And then the frog couldn't go down and is forced up as I gently pull it up, and it ends up in the plastic bag. Worked very well. And then you get a frog. So frog in a bag. And this, you can see here. So these Pinewoods tree frogs are scientific name Dryophytes femoralis, femoralis referring to the femur. And here on the back of the thigh, you can see these distinctive yellow-orange spots. And so I can see the frog, Pinewoods tree frog, goes back in the pipe. But yeah, so every time I went to the plots, I went ahead and counted how many frogs I saw and which pipes they were. So when I was counting the frogs, I was counting them on a daily basis, but I wanted to go ahead and average, get plot level variables. So this was going to be the average number of frogs per check, proportion of time occupied, and the time to colonization. So this is a hypothetical plot. So it's the 6-week study. I was checking it twice a week. So there are 6 instances of frogs. And so I saw 6 total frogs, and there were 12 checks. So I saw half a frog per check. And then for the proportion of time occupied, that was each time a plot was occupied, there was 1 occupancy. So right here on the 24th, there are 2 frogs, but that counts as 1 occupancy because the plot was occupied once. So this ended up being 5 out of 12 for about 40% of the time. And time to colonization is just the first time you see a frog in the study, and that was 7 days in. These ended up being pretty similar to each other just because we didn't end up seeing more than 2 frogs in the same pipe at the same time, but they are slightly different. Cool. So what was I expecting to see with these different frog parameters? So with respect to occupancy, I was thinking that as time since fire would increase, the average number of frogs per check would increase and the proportion of time occupied would increase. And then as time since fire increases, time to colonization would decrease. Generally, because of those differences in the vegetation that I was predicting, I was expecting to see that vegetation and weather, that the at the plot level, as time since fire would increase, I would see more frogs. And not thinking. Cool. Okay. So this is some of the things that I wanted to look at. So looking at the vegetation differences, there were these 4 different parameters that I looked at, and I wanted to do a Kruskal-Wallis analysis, rank sum test to figure out if there was a difference between the time since fire on the different vegetation parameters. I saw that there was a significant effect of time since fire on percent bare ground and a positive trend with increasing time since fire on max strobe height, although that is not significant. And then when I did an analysis of specifically the percent bare ground and seeing which pair of years or which pair of time since fires was creating that difference, I can see specifically that the time since fire equals 22 and time since fire equals 2 were significantly different from each other. So this one. But that means that the 22 wasn't different from 9 and 9 wasn't different than 2 significantly. And so I did the same thing again with the microclimate differences, and I was looking at humidity and temperature, minimum and maximum. And I found that there was a significant effect of time since fire on minimum temperature, and that was specifically between 9 and 2, which is a little strange and not necessarily these trends that we've been seeing, but talk about that more if anyone has questions on that, why that might be. Then for wetlands, we didn't find any significant, touch the mic, sorry people on Zoom. So we didn't find any significant variance of time since fire with these different wetland parameters. And that is good. That means we were controlling for that, which was our goal with this. So they definitely vary between the plots. So this isn't going to be having an outsized influence, which is nice to know. This is another way of visualizing what we've been talking about. So with the different variables that I mentioned, there were only significant effects with percent bare ground and minimum temperature. And so in this PCA, we're condensing all of these plot variables into just 2 coordinates. The principal components 1 and 2 only explain about 53.5% of the variance, but we can see that there's just a lot of overlap between these 3 groups. They're not that different within the parameters that we measured, and so there's just a lot of overlap there. So now I wanted to talk about these frog parameters. How do they vary with the time since fire? And the answer is not that much. There's not a significant effect of time since fire on any of the frog variables, whether that be the average number of frogs per check, proportion of time occupied, or time to colonization. So is there another thing that we can say that is explaining this difference? Because we did see different amounts of frogs. So we wanted to go ahead then and look at some logistic regression and model averaging. So we did a logistic regression on frog presence overall, so whether or not a plot had ever been occupied by a frog. There were 30 plots, and 13 of those plots had ever been occupied. And so we looked at a bunch of different models that were combining the different vegetation parameters. And so the top models that came out were distance to pine and distance to pine plus wetland area within 100 meters of the plot. And these were the top models with a delta I of less than 2, but there were several other plots that included different combinations like percent bare ground plus distance to pine, minimum temperature plus canopy cover, et cetera, or with more parameters. And so when we went ahead and did model averaging of these 2, just the single parameters from each of them, we found that only distance to pine had a 95% confidence interval that didn't overlap 0, which means that the distance to pine has a significant effect on frog presence. And so now we wanted to go ahead and look at, can distance to pine explain some of these variables in a better relationship than with just time since fire? And so what we have here are the log of average number of frogs and log of proportion of time occupied, because the data was slightly curved, although there's doesn't seem very explanatory in terms of the correlation. These are still pretty low, but there is a significant effect of distance to nearest pine on these two. It's just that there are a lot of zeros because, as I mentioned before, only 13 of the plots were ever occupied. So there are just not too many points to work with here. And then with respect to time to colonization versus distance to pine, there wasn't a significant effect of nearest pine. So what does it mean? So what we found basically is that there was little effect of time since fire on vegetation or microclimate. There was a significant effect on percent bare ground and minimum temperature. But overall, these were fairly, yeah, there weren't effects on any of the other parameters. Time since fire did not significantly affect tree frog occupancy, but we did find that tree frog presence was significantly affected by the distance to nearest pine, specifically the average number of frogs per check, and the proportion of time occupied increases as time since fire increases. There was no evidence of an effect on time to colonization, though. Some things that we can think about in the future about what to do with this and what it could mean. We can look more directly at the relationship between distance to pine, and we can see things about, like, does frog occupancy vary with pine tree distance differently at different times of year? So one of the reasons why we think that the frogs might be closer to the pine trees is there have been recent studies showing that the frogs use the pine trees to escape from fires by climbing up into the trees. And so do the frogs get closer to the trees when there's more risk of fire and farther away when there's less risk at different times of the year? And is there a difference in the use of slash and sand pines by the frogs over the course, is there a difference in the use of those two species? We didn't find a difference in the effect of those two species, but are they actually using them going up? Like, what are the differences there? Also, does frog size vary with time since fire or other plot characteristics? In the study, we didn't end up marking the frogs because of the constraints of the study, but we could see there if the frog size was varying with these things. I'd like to thank all of these people for their help. Any questions?
So this might be a sort of silly question, but there's a lot of smoke blowing over from the pasture today. Do you think the Pinewoods treefrogs are all climbing up the pine trees today?
I don't know. There have been, so this study took place during the non-breeding season in February and March. And at that point, I hadn't really heard any of the frogs in the trees. So I know now that, like, we're now entering the breeding season and I can hear the frogs in the trees. I don't know how many of them have been there this whole time and how many of them are going to the trees now, but it could be something that could be an indicator for them to go up to the trees for fire escaping reasons. And they don't really die that much during fires. They have pretty low mortalities during fires, so they could be escaping. Wait, sorry, hand go up. Yeah, so the tree frogs are pretty small and they are just pretty, like, abundant prey item because they're pretty common in the scrub. So I would say mostly as a prey item, pretty low on the food chain. Sure. So there are the 5 other species. The Cuban tree frogs I've seen on station before, but I think that they're probably not in the more natural habitat once you get farther away from the station. I did have some plots, the 2014 plots, which is the intermediate time since fire, are behind the, like, just across the railroad tracks. And so they seem to be close enough that there could have been some there, but I didn't find any. I'm guessing that they're mostly just in a more urban habitat. Barking tree frogs are pretty rare, and so it makes sense that we didn't find too many of those. Green tree frogs are more around aquatic places I've seen, so I think it might also be that. And for squirrel tree frogs, I just don't think they're as common as pinewood tree frogs in the area that we were looking at.